Hello. Today we are going to be solving systems by graphing, part B, or the second half of the lesson the day before. So this first problem here, I'm just going to quickly recap what we did yesterday. So yesterday we had one equation that was in slope-intercept form. The second equation was not, so we have to solve this for y. So I need to subtract 4x from both sides. So I have negative 4x, right? Your x is first, then my b. Now I can go ahead and graph these two. So first I'm going to graph the line that I just boxed with my black ink. So I have my y-intercept is 4, my slope is 2. So I'm going to graph here at 4, and I'm going up 2 over 1. And then I need to fill my graph. So I'm going to have to do the exact opposite. So down 2, left 1, down 2, left 1. Keep going until you fill your graph. Okay, so that's my first line. Now my second line I will do in red here. So my y-intercept is negative 2. My slope, let me write that down, sorry, is negative 4. Good. So I have to go down 4, right 1. This is a decreasing line, so make sure your line is going down. Then I have to do the exact opposite. So I'll go up 4, left 1. Oh, there's my bullseye. So that's where the dots intersect. And from this bullseye, I keep going up 4 over 1 because we want to finish out that line with as many dots as we can. Okay, so this bullseye, that's my solution. I have to write that down in a point form. So I have negative 1, comma 2. Great, okay. And yesterday we checked our solutions by plugging them into the equation. So let's just do that real quick down below here. I'm plugging in to this top equation. I'm going to do a little bit in my head. So 2 is my y, negative 1 is my x. Okay, so I have 2 is equal to negative 2 plus 4. Would you look at that? 2 equals 2, so that's good. Then I'm going to plug into my original equation up here. So 2 is my y, negative 1 is my x. Okay, so negative 4 plus 2. Perfect. Negative 2 equals negative 2. We're good. All right, that took me about 15 seconds to check my answer. And now I know that my problem or my solution is completely correct. So I highly recommend you get in the habit of doing that. Okay, so now this is the new one for today. If you notice, both equations are not in slope-intercept form. So I have to solve both of these for y, then graph. So subtract 3x from both sides. Okay, then divide by 2. So I have y equals negative 3 halves x plus 6. Okay, and the second one here, I have y equals negative 3x plus 6. Okay, so first one here, I will graph. So my y-intercept is 6. 1, 2, 6. Okay, and then my slope is negative 3 halves. Remember, I'm looking at my equation here. So that's down 3, right 2. All right, so fill up your graph as many as you can. And my second line, my y-intercept is at 6 as well. Oh, that's already my bullseye. But I need to keep filling up my graph, though, because I need to graph the 2 lines. Otherwise, you're not showing all of your work. Okay, so I'm going to draw my line like that. Okay, so my solution, my bullseye point is 0, 6. Okay, so I'm plugging that back into both my equations. I'll just show in green here. 6 is equal to negative 3 halves times 0. This is just 0, so 6 equals 6. Nice. And then 6 is equal to negative 3 times 0 plus 6. Again, 6 equals 6. Okay, so we're good. We checked our answers. Okay, on the back side. So first problem here, we have to solve one of them for y. So let's subtract 2x. So I have 4y is equal to negative 2x plus 8. Divide everything by 4. Running out of room. So y equals negative 1/2 x plus 2. Because 8 divided by 4 is 2. Okay, let me write a different color here. So my slope is negative 1/2. My y-intercept is 2. All right, now let's solve this next one for y. Okay, so I have negative x over 2. That's a negative 1 over 2. So I have negative 1/2 x plus 2. All right, I'll use green. So my slope is negative 1/2. My y-intercept is 2. Ooh, it says down below, using the slopes, how are these lines related? So let's look at our slopes. Our slopes are the same. Okay, last chapter we talked about that. If the slopes are the same, what is that called? Good, parallel. Very nice. Oops, sorry, parallel. Okay, and then it's saying, do lines intersect? Parallel lines don't intersect. But let's graph this first before we answer that question. So I'm going to graph this first equation in red. So my y-intercept is 2. I'm going down 1, right 2. Okay, that's the first equation. Now the second equation. Ooh, this is going to be strange. My y-intercept is also 2, and my slope is the same. Okay, so the lines are literally the exact same line. So do lines intersect? Yeah, they're the same line. Yes, they're the same line. So how do you think we could write our solution? Because basically we're saying here that literally any point on this line will work. And even if I keep making this line longer and the graph bigger and bigger, I'm still going to have more answer choices because that line's going to keep going forever. So think back to our solving equations chapter. We have 2 special cases that we can come across. So what do you think this one is? What should be infinitely many solutions. So when you have the same line, it's infinitely many solutions because it's intersecting at every single point. Okay, then last one here, we have to solve both for y again. Okay, so I will subtract 2x. Make sure you watch your negatives. So negative divided by negative is a positive 2/3 x. Negative 6 divided by negative 3, positive 2. Okay, and then for the second equation, make sure your number says 24 on your page. If not, change it real quick. Okay, so now I'm going to answer my slope is 2/3. My y-intercept is 2, or 0, comma 2. That would probably be even better. Okay, and then next one, my slope is 2/3, and my y-intercept would be 0, comma 4. All right, so let's graph the line in red. So start at 0, comma 2, go up to right 3, up to right 3, down to left 3. Nice. Okay, and then my line in green, my y-intercept is 4, up to right 3, down to left 3, down to left 3. Okay, so we have these two lines graphed and saying using the slopes, how are the lines related? So again, the slopes are the same, just like up above. So let's say, okay, they're parallel. Now it's saying, do the lines intersect? Are they ever going to touch? No, good. They are just going to keep increasing by the same amount, so they will never intersect. All right, so my solution, if up above it was infinitely many, when they always intersect. If they never intersect, that means nothing is ever going to work. No point is an option, so we say no solution. Okay, and that's it today for our graphing part 2.